All right, guys. Assalamu alaikum. Apologies about the delayed start again. We need to fix this. Nonetheless, let's continue. So, in our last class, what we did was we started off with limits of accuracy, and we discussed how to round off and how to, round off to a particular significant figure. And we also discussed what are exact values, and we also saw what essentially is the difference between rounding off and estimation as well. Now, today, what we're going to look into is how do you look at bounds, upper bounds, lower bounds, and stuff of that sort. So, in today's class, we will be discussing that. Hmm. Now, this is again, the topic itself is very, very paper two oriented. And the reason for that is just a moment, guys. So, what we're going to have is that we saw yesterday that, what's the main difference between rounding off and estimation. And today we are going to look into, what you may call bounds, upper bounds and lower bounds. So, can anyone describe what are bounds? Yes. Is there anyone who has any idea what are bounds? Yes. What are bounds, guys? Come on.
Yes, there are two, sir, there are two types of bounds, upper bounds and lower bounds.
Very well done, Basit. Two types of bounds. You're absolutely right. Upper bound and lower bound. Okay. Um, Explain them to me in a bit further. Like, what could they possibly be? What would these two types of bounds could be? Yes.
Like upper bound is a little bit bigger value, like you if it is closer to 1 decibel place, you can add 0.05 to it to make it upper bound, and minus 0.05 to make it lower bound.
Wow, Basit. That is excellent. Yes, Basit is absolutely right. Whenever we talk about, any sort of bounds, whenever we're talking about trying to round it off to a particular, bounds and stuff, we're always going to be concerned with two aspects of it, which is going to be your upper and lower bound. All right, so we're going to have upper bounds, and at the same time, we're also going to have lower bounds. And just as Basit said, it is just another way of, trying to what you may call round off or use, any sort of limit of accuracy that we're trying to do. So if your answer, we're just trying to make the answer a bit more accessible and easy to us. Keeping this in mind, how do you get to bounds is the main question. So whenever a question is given to me in terms of, wherever it says, use bounds to calculate this answer and stuff of that sort, over here, a bit of brain power from you guys is going to be required as well. Because even though there is no set standard for it, you can still actually, get upper bounds and lower bounds from it. For example, just by understanding what the question is all about. So, for example, if there's a fraction and they ask you to get the highest possible value out of that fraction, obviously I know that if my denominator is a very big number, then my overall number is going to have it's going to be small. The reason for that is because of the fact that my if you're dividing by a larger number, your in total fraction is going to be really small. Whereas if your numerator is greater than your denominator, you're going to have what you may call uh, a larger number. Now, always remember that these bounds are essentially, if we were to simplify what bounds are, they are essentially, you can call a range of values, or you can say range of values in between a rounded of number, or a rounded of any number can exist. All right. So any value, any range of values that you can, use, so that that rounded off number could have existed in between those. Now, for example, um, if your final answer is 10, so that means if 10 has gone through the process of rounding off, that means it can be anything greater than 5, right? All these 5, 6, 7, 8, and 9, they are all rounded off to 10. So that means my number can be either one of them if 10 was, supposedly the answer of a rounding off. Similar is the case with lower bound as well. Whatever numbers that can actually revert back to their original number are known as your lower bounds. Okay. Now what's going to happen? We are going to suppose a number x. We are going to suppose a certain number x. Now that number has to exist within the lower bound, and that number has to be less than the upper bound. The reason why the upper bound is not included in that number is because the when we get to the calculation of the upper bound, you'll know that if my value is exactly upper bound, it is not going to round off to the actual number again. It is going to round off to the next number, and we'll see how that happens. So your lower bound is going to exist over here. Now we need to understand how to differentiate between, your lower bound and upper bound, and how to actually get to the number. First off, let's look at a question. So let's just say that, for example, you can say, hmm, 35700 uh, to the nearest thousand. So this has already been rounded off. This is already rounded off to the nearest, let's just say 100. Okay, this has been already rounded off to the nearest 100. Now, if I want to calculate my, what you may call, my upper bound and lower bound, I need to first know the degree of accuracy I need to know. All right, so I need to know what is the degree of accuracy and what is its midpoint. So technically, my degree of accuracy is this guy. And I need to divide this by 2 in order to get the midpoint, or in order to get some sort of value. So it's going to be what, for in this scenario, it's going to be 100 over a 2, which is equal to 50. Keeping this in mind, now I know that my halfway point was 50. So whatever number, before rounding this off, whatever number existed above 35750, was rounded off to, oh, 35650 was rounded off to a 700. Clear? Now, how do you do this? This value, whatever value you're going to get, this value that we're talking about and this value that we're going to get, you can do it, you can do this in two ways. If this value is added to the original number, that means that you're calculating what? Upper bound. And if this has been subtracted from the original number, that means it's lower bound. Okay, let's see. So if I need to calculate my 3570 and calculate its upper bound and lower bound, technically what I want to know is what was the range in which my number before rounding it off could have lied in order to get to this number. In order to get to this rounded off figure, my original number would have lied in some minimum and maximum value so that it could have been rounded off to this guy. So let's see now. Now, from this question, let's try to look at this question. So, for example, if you're asked to calculate the upper bound, that is simply going to be my original number, 35700, plus whatever you did with the degree of accuracy divided by 2. So, the plus the midpoint, that is for my upper bound. So, that is 50. So, this is going to be equal to 35750. Let's look at lower bound. So, now if I'm calculating lower bound, what is going to happen is 35750 minus 50 is equal to 35650. Is this clear? So now I know that my original number would have lied somewhere in the vicinity of, that x would have been, obviously it would have been equal to and greater than 35650, and it's obviously going to be less than what you may call the upper bound, which is 35750. Now, the reason why we include this number and why we do not include this number is because if your original number was 35750, then it would not have been rounded off back to 35700. It would have rounded off to 35800 on to the next. So that is why we do not include it over here, but we do include it over here. So the only thing that you guys need to understand is that while doing these type of questions, you just need to know how to calculate your upper bound and lower bound. And how you're going to do that is plain simple. That's simply you're going to what you may call divide your degree of accuracy, which was given to you over here, nearest 100, nearest 1000, whatever it is, by 2. And if you're adding that number to the original number, it's upper bound. If you're subtracting that from the original number, it's lower bound. Is this clear? Anyone who does not get this, let me know right now. Hopefully this is clear. Yeah, someone's got their hand up. Yes, sir.
So in this case, the upper bound will be 35750 or 35749.
What, sorry, Saad? Yes, okay. For now, Saad, I'm telling you the range of values that you're doing. When we look into exact values, then you're right. We're obviously going to take any value which is less than this. So whatever value is allowed to me. So I can write 35749. Yes. You can take any value, it needs to be less than this. Right now, I'm just teaching you on a broader scale. When we move into calculations, this is just to identify what is bounds. When we move into calculation, addition, subtraction, then we'll see, what numbers we can use, what we should use. Clear?
Yes.
All right. Now, this is very plain and simple. You're just trying to find the range of values in between a rounded off, where a rounded off number can exist and stuff of that sort. But whenever you're calculating something and you're doing some sort of calculation involving two certain numbers which are adding, subtracting, multiplying, or dividing, not at the same time, but anything could happen. That is when you may have what you may call, what Saad was telling us, that you may have to use upper bound and lower bound, differently. And also this can come that in a same question, in one question, you could get maybe, you maybe have to use upper bound and lower bound for the same value in the same question. Is this clear? So that can happen as well. Now, for example, let's just, this was really easy. I found this somewhere a while ago, and I thought it was, you know, much more easier to understand rather than, I will obviously explain it, but I think this is much more easier to understand. Let's make a table of some sort and let's see what we need to do. So over here, we're going to have different columns. The last column is too big. So it's going to be what you may call upper bound, lower bound, and we're going to look at different operations. So for example, let's just take two numbers. Any two numbers can suffice. So for example, what if x plus y are adding together? And if two numbers are adding together and the examiner wants an upper bound of the answer, you're simply going to multiply the add the take upper bounds of both and add them together. Is this clear, guys? And same case scenario for lower bound as well. If two things are adding together, and the question asks you to find the lower bound for them, you can just simply calculate the lower bound for both of them individually, and then just add them together. Now, secondly, we have, we can say that what if x minus y? Now, if they ask you to find the upper bound of two things being subtracted, what how should I do it? Now, they're asking me the maximum possible value I can get for two things that are subtracting. Yes. Hello, can you hear me? Who was this? Yes, Rani.
Yes, sir.
Yes, Rani, were you saying something?
No.
All right. So, whenever you have x minus y, now if I want to get a larger answer, my final answer needs to be in an upper bound. It needs to be the maximum most answer I can get. That means that I need to subtract x with something less. All right. So I need the least possible value of y and the most possible value of x in order to get, the maximum possible value I can get without changing the numbers. So what I'm going to do, if two things are subtracting from one another, you do upper minus lower. And now, if you're going to get one, if you want the lower bound, you're simply going to do lower minus upper. Clear? Now, this is easy in terms of, because of the fact that it's addition and subtraction. Things get a bit interesting when you multiply. Now, if you're multiplying two numbers and the examiner says to calculate the maximum possible value that you can calculate for that number, the technically upper bound is what? It's the maximum value that that number can go to without having to change the number so that it can still be rounded off back to the original number. So it's the distance can you can increase the distance to the most maximum amount. And what is going to happen is that this is the upper bound is actually the range, the maximum value possible of the range of values that can exist for your number. So when you're multiplying together, obviously it's going to be the same thing. You multiply upper with upper in order to get a larger number. You're simply going to multiply with a larger number. All right, like this. And you're going to multiply, the same thing goes on with what you may call the smaller lower number as well. Both lower numbers will be taken and they'll be multiplied. Same case scenario for division. Now, if I'm dividing two things, like for example, A divided by B, what is going to happen is that now this is a bit more interesting. Why is it a bit more interesting is because if I'm dividing something by like for example A divided by B, and I want to get the maximum possible answer for this, like the maximum range of this answer I want to calculate. So that means I need my denominator to be really small and my numerator to be really big, because whatever you're dividing it with needs to be really small and the numerator needs to be somewhat bigger in order to get a larger or the maximum possible answer that you can get. So simply you're going to apply again the rules of um, what you may call subtraction, and it's going to be upper divided by lower and lower divided by upper when it's vice versa on the other end. Is this clear, guys? Is there anyone who doesn't understand this? I don't know why I started using X and Y and A and B all of a sudden, but okay. Yes, anyone who does not get this, let me know. All right, hopefully this is clear. Now what we're going to move on is that we're going to see a question. And questions regarding upper and lower bounds are not that hard. Wait, let me try and take out a question, a past paper question, if I can manage to. So whatever happens is that your level of accuracy needs to be, adjudged first. Whatever, howsoever you're accurate, you need to judge that first. So what's going to happen is we will just see that it's going to be, where did it go? Let me see, take out a question. Uh, I think there should be a question. Hmm. Yes, well done. Hmm. The reason why I'm not giving you guys the worksheet in your other class is because I think this topic is too easy. You guys can do it right now. There's no need to wait around for it. I think it's better to post the worksheet on Google Classroom. Just give me a moment, guys. Just a moment. I'll be posting the worksheet on Google Classroom. Go through your notes and let me know if there's anything you don't get. All right, let's see to it. So I found this question. I think you guys can calculate this. And by the way, bounds can also, even though this is predominantly um, paper 2, you guys can still find questions regarding bounds in paper 4 as well, because it's a bit more about mental aptitude rather than, hmm, just give me a moment. I'll post it in Google Classroom so that everyone has access to it. Um, hmm, just a moment, guys. Hmm. There's a 4 marker question in there as well. I want to especially see how you guys attempt that. And hmm. Yes. And do not be confused if the question requires some sort of formula from you. It's going to be any formula that the question requires from you is going to be very, very basic and simple. Probably in the questions that I've sent, it's just asking for average speed and stuff of that sort, which I think you guys can like. I think you guys can do. So let's just write this down on Google Classroom and kindly. The questions are very easy. I want you to do them right now in this class, and we'll try to check them as well. Upper and lower bound. Hmm. Yes, people, the assignment's up on Google Classroom. Go to it. Kindly let me know if you've received it.
Yeah, I got it.
All right, Joel. That's good. Kindly do it right now, guys. And should we mark it as well? Wait, I think I should mark it as well. We can though. It's fun if we mark it. How many questions is the first question? It's 3 markers. 2, 5, 7. 7 plus 7 is 14. So I'll mark it out of a 15. It's like a tiny worksheet. Someone got their hand up. Yes, Fahad.
So do I need to submit it, or like can we just do it in class and then you'll go through it?
You guys can submit it, but I just want to go through it in class as well. So it'll be naturally checked. All right, Fahad.
Okay, sir.
You guys can check your answer over here and just let me know how many marks you get. We can even do that. We can even mark it like that. Kindly do it and let me know. Yes, guys, are you done?
Yes, sir.
All right. Who else has done? Zoya, are you done?
I'm on the last question, sir.
All right. And what about you, Hani?
Almost done, sir.
All right. And Ranim and Basit?
I'm still doing it.
Almost done.
All right. I thought we would be able to discuss it in class. I think we can still, as time is left, but huh, no worries. Fahad, were the questions easy?
Yes, sir.
See, this is not really hard. I have belief in you guys that this is not hard. These are all past paper questions, so it shouldn't be. You guys are doing them right now easily, and it shouldn't be an issue if they come in the exam as well, like this.
Done, sir.
Done? Who was that? There?
Yes.
All right. Now, unfortunately, you guys have left me with very little time. How about you guys submit it on Google Classroom? I'll check it over there. I wanted to discuss it in class, but I'm afraid I'll have to check it over there. Also, the total marks for the worksheet were 14. And the reason why I'm marking it out of 8 is because Zoya is going to get a bonus mark. And can anyone tell me why? Is that the case? Yes, people. Any idea why am I giving Zoya one free mark? Because of the very simple fact that she shows up on time. So the rest of you are going to be marked out of 14. Zoya is going to be marked out of a 15. Nonetheless, we'll keep it till here for today. Kindly be on time. I will as well. I'll begin on time as well. And I'll see you guys on Monday now. And do before you leave the class, do submit your work on Google Classroom. Otherwise, I won't mark it. Once you're done, you can leave the class.
Sir,
But
I've done like really rough working, so like, do I do it again?
no, Father, I think I can understand it.
Okay, sir.
If I don't, I'll let you know. No worries.
Allah Hafiz, sir.
Allah Hafiz. So whoever submits it can leave. Yes, Rani. Done with it or no?
I'm still doing it. Sir, I'll submit it. Can I leave the meeting?
Yeah, sure. But do send it to me, okay?
Okay. Allah Hafiz, sir.
Well,